Hi, and welcome back. I had a request from a viewer to look at this EQ plugin. It's on sale at the moment. Hopefully I can get this video out while that remains the case. But my viewer was especially concerned about what he thought looked like cramping in Plugin Doctor. Spoiler alert, it isn't cramping. He's misinterpreted the graph. I wanted to mention that now, in case people quit my video early with the wrong impression. But let's see if we can find out what's actually going on. We'll get to the Plugin Doctor stuff shortly. Let's just have a listen to it first. Actually, I should perhaps point out that while Plugin Doctor features heavily in my review videos, I don't normally use it to assess the quality of a plugin. There's only one test that matters, really. Does this plugin get my mix closer to finished? For example, I know a lot of you got a free copy of Compressor recently from IK Multimedia. I've had my copy a little longer than that, in fact, and I've been using it a lot, especially on kick drum, but also other elements, and even the mix bus once. No doubt one day I'll load it into the Doctor and see what it's doing. Maybe I'll make a video about it. But I don't need the Doctor to tell me it's a useful plugin that gives me good results. Anyway, back to the SSL. And it doesn't take long to sum up the feature set. A high-pass filter with a choice of 3 cutoff frequencies and a fat button. A low shelf with 4 frequency options and plus or minus 9 dB gain range, and a high shelf with the same options. There's also a brace of gain controls for input and output, and an echo button at the bottom, which takes away the latency. So the first question that springs to mind is, why would I load this plugin rather than one of my many other EQ plugins that also provide mid-range bands as well as low and high shelves? It seems to me that there needs to be something special in this plugin to justify its existence. And there are only 2 ways I can think of that this can be true. Either there's something unique and special about the EQ curves this produces, which would be difficult to replicate in a standard EQ, or there's some special saturation magic sauce adding extra harmonics, as well as just boosting or cutting those already present. A couple of things suggest the latter is the case. Why would you provide separate input and output gains if the gain structure through the plugin wasn't important? And oversampling. The most likely explanation of the latency is linear phase oversampling filters. Eco mode is supposed to reduce the CPU load as well as eliminate the latency, so my guess is this turns off the oversampling. But it might switch to minimum phase oversampling instead. We'll find out in the Doctor shortly. Anyway, there are 2 reasons you might want to oversample an EQ plugin. It fixes the cramping, and it reduces aliasing from non-linearities. There are other ways to decramp an EQ, however, arguably more elegant ways than oversampling, which is kind of a brute force approach. FabFilter Pro Q3 produces decramped curves with neither latency nor oversampling, and there are plenty others that can do that too. But if there are non-linearities in the plugin, the only way to prevent or reduce aliasing is oversampling. So we have 2 clues suggesting that the plugin is non-linear and adds harmonics. The separate input and output gains and the use of oversampling both suggest this strongly to me. But there is some countervailing evidence also. I read through the marketing blurb carefully. Of course, they're very keen to use words such as analog and sheen and modelling, and naturally want you to think you're getting a slice of the classic SSL analog sound. But they're rather more careful than another classic console manufacturer that I've criticised for their hyperbolic marketing. No misleading talk of every resistor and capacitor here. In fact, their description of the process seems quite reasonable to me.
Modelled using a combination of real-life measurements, analog circuit designs, and close collaboration with the original analog designers of the SSL Fusion hardware, and validated by real-world producers.
Most significantly, I can't find any mention of saturation or non-linearity anywhere in their description. And I think they would probably mention it if it were there, right? So the first thing I want to do is try changing the gain structure through the plugin and listen for any difference in sound. Now I wonder, is there a mouse modifier I can use so that when I turn up the input gain, the output gain is reduced to compensate? No, apparently not. How annoying. A message to plugin designers: we can only adjust 1 knob at a time in the box. Please give us 1 single control with which to change our gain structure. It makes life so much easier. So I'm going to inverse link the output gain to the input gain using Reaper's parameter linking. This isn't a proper solution really, as it means I've now got no way to gain compensate the EQ setting. But at least it means I can easily try out different gain structures. Can you hear a difference? I can't. We'll double check in the Doctor shortly, but I'm thinking this is completely clean and linear, meaning the two gain controls are a pointless and slightly misleading duplication of parameters, and this irritates me a little. Okay, so what about the special magic EQ curves? There's no doubt that this rather extreme plus 9 dB high shelf boost sounds surprisingly good on this full mix. But I've specifically chosen a very warm sounding mix that can take a lot of boost at the high end. So the question is, do these SSL curves sound better, or even just different, to other EQ plugins that I already own? This question goes beyond simply, can I match the curves with something like Pro Q3, which I will attempt to do before the end of the video. It also includes the question, am I likely to arrive at an equivalent curve when using a different EQ? So my first test won't be scientific at all. I'm just going to load a few different EQ plugins, dial in the low and high shelves to taste without specifically trying to match anything, and let's see if the SSL stands out in any way. Well, they all ended up sounding slightly different, but they're all much closer to each other than to the original mix. Which now sounds disgustingly muffled by comparison. Did the SSL do noticeably better than the others to your ears? I'll admit, I'm not really convinced. The main difference I noticed, the SSL high shelf claims to be 8 kHz, but when just guided by my ears, I've ended up significantly lower in all the other plugins, more like 4 kHz or lower. Alright then, let's turn to the Doctor and see if my ears were fooling me. And I'll start with the Harmonic Analysis tab. Actually, on the off chance that the DDMF developer is watching, here's a request to make the Harmonic Analysis tab the default tab instead of Linear Analysis, to encourage people to check for nonlinearities first. But in this case, we're clean. No harmonics at all, just as my ears told me. That means two things. We're safe to analyse the curves with the Linear Analysis tab, and we need to find something special about those curves to justify why this plugin exists at all. Let's start with the high-pass filter. Looks pretty normal to me. Here's Pro Q3 matching it perfectly with an 18 dB per octave slope. What about that fat button? It adds low-end punch, according to the marketing. Just looks like a bit of resonance to me, however. Sure enough, if I turn up the Q in Q3, looks just the same. Punch suggests to me some kind of dynamic behaviour, like the very subtle low-frequency compression I found in Pulsar Massive. But I can't see any evidence of this in the Dynamics tab when I enable Fat mode, nor can I see any harmonics appearing in the Harmonic Analysis, so I'm going to conclude that this really is just a bit of resonance for a linear filter. Okay, what about the low shelf? Again, it's looking very normal and unremarkable. Here's Pro Q3, matching it pretty much exactly. I've needed half a dB more gain in Q3 than the 9 dB the SSL claims, but that doesn't matter at all. More significantly, I needed to increase the slope in Q3 to 18 dB and set a lower Q to compensate before the curves matched this closely. That's something that may simply not occur to you to try in Q3. Then again, the difference is minuscule. Here's the closest I got using the default 12 dB slope. I find it hard to believe that difference matters at all. Now, before we move on to the high shelf, we need to talk about what's already happening up in the high frequencies. There's a very subtle lift above 10K, as if the high shelf is already boosting slightly. And there's this steep low-pass filter up above 20 kHz. That high-frequency boost doesn't appear to be affected by the high shelf frequency control, so I'm concluding it's not related and it's just a constant, very subtle box tone that's there all the time. And of course, the low-pass filter is for the oversampling. Its job is to remove all content above half the sample rate, and this looks like it's doing just that. And in fact, I think this is what my viewer misinterpreted as cramping in his test. So let's see how the eco option affects this filter. Does it go away as I expected? Well, it's tempting to conclude it does, but actually I still see the start of a filter roll-off up at the top there. Perhaps we actually now have minimum phase oversampling with cheaper filters that don't roll off as steeply. We can get a further clue by checking the phase response. Here's the default setting with eco turned off. We do have some gentle phase shift, but this looks like it belongs to the box tone high frequency boost, as minimum phase oversampling filters tend to cause much more phase shift than this. Rather like this, in fact. Yes, that looks like minimum phase oversampling with eco turned on. Looks a mess, right? Still, totally inaudible in most cases. Don't fear the phase shift. But anyway, I think we've got our answer. Violet uses linear phase oversampling by default, but switches to zero latency minimum phase oversampling in eco mode, rather than just dropping the oversampling entirely and running at the project sample rate, as I guessed. So what if your project sample rate is 96K or even higher? Well, it seems like the oversampling goes away. Actually, the biggest clue is that the latency drops to zero at higher project sample rates, even with the eco turned off. It's a little difficult to be certain that there's no anti-aliasing filter, as we're now seeing a low-pass filter at about 30 kHz. But the most likely explanation, it seems to me, is that we have 2 times oversampling when running at 44.1 or 48 kHz, but at higher rates it just runs at the native project sample rate, and there doesn't appear to be any difference at all with eco on or off. Okay, let's switch back to a 48K sample rate and have a look at the high shelf. There's a 9 dB boost at, supposedly, 8 kHz. And here's as close as I can get to that in Q3. Note that I'm down at around 3 kHz in Q3 though, to match an 8K setting in Violet. It's pretty close. Not quite as close as I got to the low shelf, however. I'm wondering now how much that has to do with that subtle box tone high frequency boost, however. And when I test at 96 kHz, this starts to look like the residual boost from some resonance in that 30 kHz low-pass filter. So let's see if I can match that low-pass filter in Q3 first, and if that then results in a closer match with the high shelf boost. Interestingly, I can't. Matching the steepness of the roll-off requires a surprisingly steep 48 dB setting in Q3. But then the region between 10 and 20K is completely wrong, and that's way more important. So I'm going to conclude that the 18 dB slope gives the best match, because I can't hear anything up at 30 kHz and I'm not embarrassed to admit it. So can I match the high shelf curves better now? Yes, a bit. Does that difference matter at all? Probably not, no, in my own opinion. But hang on, you may now be saying, you're still running them at 96K. Surely Q3 can't do a 30 kHz low-pass filter with normal sample rates? But actually, yes it can. Don't ask me how, but there it is. And the curves still match more closely with that filter switched in as well. So there we have it. It's a clean, linear shelving EQ with only very minor differences in the curves compared to the FabFilter EQ. There remains only one reason I can think of to load this instead of any other decent EQ plugin. The SSL name, with their undoubted pedigree in console design and analog processing, together with the unconventional calibration of the frequency controls, gives you the confidence to apply a high shelf boost at 3K for your whole mix. And this is officially sanctioned as OK by the SSL engineers. If you're a bit insecure in your mixing decisions, perhaps you would balk at such a setting in any other EQ. You might worry that shelves are supposed to be up at 8K or higher, and that you're doing something wrong that your ears aren't good enough to warn you about. That might have been me at one point, but I don't think I fit that category any longer. I trust my ears to choose which frequencies to boost or cut, and I don't need those decisions validated by anyone else. And I already own a plethora of EQ plugins with shelving filters, most of which can also fix my mid-range issues as well. Speaking personally, I can't find any reason to add this to my collection. If you want to buy it anyway, you'll find an affiliate link in the description. Haha, only joking. It's just a normal link. This video isn't sponsored in any way, and I'm just running the 14-day demo. Okay, that's all. Thanks for watching.